Hello, Paul Watts again here from High Flying Physics, targeting A-level physics students wanting to get top grades at A-level. This is, on the face of it, looks like a really easy question on Newton's laws. It involves a rocket accelerating vertically upwards, and students go very confidently into this and end up getting it wrong. Let's have a look why. A small rocket of mass 300 kilograms is at the point of takeoff. The rocket engine produces an upwards thrust of 4,500 newtons. And we've got two things to do. What is its acceleration? And B, what engine thrust is required to give the rocket an upwards acceleration of 15 meters per second squared? So, on the face of it, dead straightforward. So we launch straight into this and we write down the formula F is equal to ma, quite right, and we say acceleration is force divided by mass. 4,500 divided by 300 is 15 meters per second squared, right? No, I'm afraid not right, absolutely. And the reason why it's not right is because F is equal to ma. The F is the unbalanced force. And there's another force acting here. So the way to approach this question is as follows. We know F is equal to ma, and the F, as I've just said, is the resultant force. There's another force acting, and the force is weight. We're told the mass of the rocket is 300 kilograms, therefore we know weight is equal to mg, which is 300 times g, which is equal to 2,940 newtons. So the resultant force is going to equal the thrust minus the weight, which is 4,500 minus the 300g, and that comes out to be 1,560 newtons. Then to work out the acceleration is F over m, so 1,560 divided by the 300, and the acceleration of the rocket is 5.2 meters per second squared. Okay, next question. What engine thrust is required to give the rocket an upward acceleration of 15 meters per second squared? In order to produce the acceleration, the engine thrust has two jobs to do. It's got to overcome the weight, and it's got to provide the unbalanced force which is making the thing accelerate. We can summarize that by saying thrust is equal to weight plus the accelerating force, or m times a. Well, we know the weight is 2,940 plus the accelerating force is the mass times the acceleration, which we want, which is 15 meters per second, and that comes out to be 7,440 newtons. Good. Hopefully then, if a question like that comes up, you won't fall into the same mistake that most students make. Okay, good. I hope you found that useful. Thanks. Bye.